Good morning to all. I am Prabha K, working as Assistant Professor in the Department of Electronics and Communication Engineering, Sai Vidya Institute of Technology, Bengaluru. Today, we'll have a discussion on the Memory System module of Computer Organization and Architecture subject. Today, we'll discuss on RAID disk arrays. RAID disk arrays are known as redundant array of independent disks. As we know already, an additional memory is required in order to speed up the operation of the processor, that is cache. In the same way, to improve the system performance, we need an additional disk. In RAID, we use an array of disks. These disks operate independently. Since there are many disks, multiple I/O requests can be handled in parallel if the data required is on separate. A single I/O operation can be handled in parallel if the data required is distributed across multiple disks. What are the benefits of RAID? As we know already, the data storage is very important uh, process in the computer system. If any data is lost, it can be dangerous for an system organization. RAID technology prevents data loss due to failure of any disk. RAID technology can be implemented either using hardware or software. And servers mainly use the RAID technology in order to store the large amount of data. Coming to the RAID technology, there are totally 7 layers of RAID schemes which are designated as or which are called as RAID 0, RAID 1, RAID 2, RAID 3, RAID 4, RAID 5 and RAID 6. And all these level of RAID technology have a common characteristics like there will be a set of physical disk drives in every RAID technology. The operating system views these separate disks as a single logical disk. Data is distributed across the physical drives of the array. Redundant disk capacity is used to store parity information. Parity information can help in recovering data in the case of disk failure. Coming to the RAID level 0, which is also called as RAID 0. This is a diagram that we need to consider. RAID level 0 divides the data which is stored into it as a blocks of units and writes them across number of disks. As data is placed across multiple disks, it is also called as data stripping. The advantage of distributing data over disk is that if two different I/O requests are pending for two different blocks of data, then there is a possibility that the requested blocks of data are present on the different disks and can be accessed parallelly, thereby reducing the access time and increasing the performance. In this level 0, there is no parity checking of data. So, if data in one drive gets corrupted, then all the data would be lost, and it does not provide support of data recovery. Spanning is another term that is used with the RAID level 0 because of logical disk will span all the physical drives. RAID 0 implementation requires minimum 2 disks. What are the advantages of a RAID level 0? Mainly, it increases the speed of access of memory. Throughput is increased because multiple data requests probably not on the same disk, assuming that it will not be on the same disk. And the disk seek in parallel. That means accessing of different disks can be done parallelly. A set of data is likely to be stripped across multiple disks. Implementation of RAID 0 level 0 is easy. No overhead or a parity calculation is involved. The major disadvantage is that there will not be any fault tolerant mechanism in order to reduce the what we can say the percentage of fault occurrence or recovery of data. The failure of just one drive will result in all data in the array being lost. And this type of memory technology should not be used in mission critical environments. Coming to the RAID level 1, the diagram shows here this method is also called as mirroring and duplexing. This level is called mirroring because it copies data onto 2 disk drives simultaneously. As same data is placed on multiple disks, it is also called as data mirroring. The automatic duplication of data means there is a little likelihood of data loss or system downtime because any of the disk failure occurs, the data will be available on the duplicate disk. Data stripping is used in RAID 0, but each logical strip is mapped to 2 separate physical drives. Same as the RAID 0, the data stripping is used, but it will be on 2 separate physical disk drives. Thus, every disk in an array has a mirror disk that contains the same data. Data can be read from either disk, but written on both the disk, that is a original disk as well as the mirroring disk or a duplicate disk. A read request can be executed by either of the 2 disks. A write request means that both the disks must be updated and which can be done parallelly. There is no overhead of storing parity information. Recovery from failure is very simple. If one of the drive fails to store the data, then the same data can be accessed from the second drive. The advantages of RAID level 1 are it provides the full tolerance level. If one disk fails, the another automatically takes over. So continuous operation can be maintained. RAID is used to store system software such as drives, OS and compilers and other highly critical files. And what are the disadvantages? The main disadvantage is cost. Since data is duplicated, the storage cost increases. Next, RAID level 2. The diagram gives you the RAID level 2 disk arrangement. In RAID 2 mechanism, all disks participate in the execution of every IO request. You can make out there are so many disks, disk 0 to disk 6, and each disk is divided into a number of block units, designating as a block A1, B1, C1, D1 in the disk 0. Similarly, you can find out there is a parity disk which can hold the parity information of the respective block units. The spindle of individual disk drives are synchronized so that each disk head is in the same position on each disk at any given time. RAID 2 is a technique that strips data at the bit level using the Hamming code to detect errors. Data stripping mechanism is used, and error correcting code is calculated and stored along with the data in the dedicated disk that we call it as a parity disk. Uses Hamming code to detect and correct the errors. The error correction code verifies the correct data or corrects the disk if any error has occurred. Extremely high data transfer rates are possible. Not implemented in practice due to the high cost and the overheads. RAID level 3 is also called as a bit interleaved parity level. From the diagram, it is clear that there are a number of disks are present. Parity will be on a separate disk. The parity of all the disk will be on all these block units of the disk will be on a separate disk. Here the data is divided by units and written across multiple disk drives. Parity information is stored for each disk section and written to a dedicated parity device. This is a dedicated parity device where you can find out the parity information related to the disk 1 block units, disk 2 block units and also disk 3 block units. All disks can be accessed parallelly. Data can be transferred in terms of bulk, thus high speed of data transmission is possible. In case of drive failure, the parity drive is accessed and the data is reconstructed from the remaining devices. If any one of the drive gets failed off, the parity information related to the drive will help to reconstruct the data. Once the failed drive is replaced, the missing data is stored in the new drive. Using this RAID 3 technology, a very high data transfer rates can be achieved. Coming to the RAID level 4, which is also called as a block interleaved parity. From the diagram, it is clear that there are a number of disks are there and along with a disk dedicated to store the parity bits with respect to the block units of the disk. Independent data disk with a shared parity disk. You can find out these are the independent data disk, whereas this is the shared parity disk. Each entire block is written into the data disk. So whatever the data is there, it will be written onto the data disk. Parity block for the same rank blocks is generated on writes, recorded on the parity disk and checked for read operation. RAID 4 strips the data across multiple disks just like a RAID 0 level. In addition to that, it also stores parity information of all the disks in a separate dedicated disk to achieve the redundancy technique. The diagram shows that the disk 4 serves as a parity disk having the parity blocks which are called as a AP, BP, CP, DP, so that if one of the disk fails, the data can be reconstructed using the parity information related to that disk. Space is more efficiently used here when compared to the RAID 1 level technology, since parity information uses a very less space comparing the mirroring technique used in the RAID 1 technology. The write performance becomes low because all parity information is written on a single disk, which is act as a bottleneck, and this problem of bottleneck occurrence can be solved using the RAID 5 level technique. What are the advantages? Efficient data redundancy in terms of cost per unit memory, performance boost for read operations due to data stripping. The major advantage is that write operation is slow. If the dedicated parity disk itself fails, data redundancy is lost. RAID level 5. It is similar to the RAID 4, but there is the parity information distributed over all the disks instead of storing them in a dedicated disk. You can make out that there are 4 disks here given in the figure. Disk 1, disk 2, disk 3, disk 4. This is the block A1, B1, C1, but also there is a parity information related to the block D. This block DP consists of parity information related to block D1 unit, D2 unit and the D3 unit. Here in the disk 2, you can make out the parity block unit, that is the CP, which is the parity information of block C1, C2 and C3, which are distributed over other disk. Block DP gives the information about the parity of B1, B2 and B3. Similarly, block AP unit of disk 4 gives the information about the parity of block A1, A2 and A3. So it is very clear here. The parity information is distributed over all the disks instead of storing in a dedicated disk. It has two major benefits. First one, there is no more bottleneck as the parity stress even out by using all the disks to store the parity information. There is no any bottleneck condition because the parity has been distributed over all the disks. Second one, there is no possibility of losing the data redundancy since one disk does not store all the parity information. The major advantage is that write speed is increased and better data redundancy is obtained. Disadvantages is that can handle up to a single disk failure. There is a chances that if the single disk failure occurs, the parity bit of the other disk will be lost. RAID level 6. It uses the double parity blocks to achieve better data redundancy compared to the RAID 5 level. You can make out here disk 1, disk 2, disk 3, disk 4, disk 5 are the multiple disks on this RAID disk array. Here the block A1, A2, A3, AP and AQ. Similarly, block D1, block B1, B2, B3, BP, BQ like that, and B3 has been come over here. This increases the fault tolerance for up to 2 drives failures in the array. So there is a very clear-cut information here. The parity is stored on multiple times. The parity information is stored in the 2 blocks which are stored in a different disk. Here you can see the parity of this block. This is the parity information related to the A1, A2, A3. Here it is called as a AP. The same parity information is stored on another disk. We call it as a AQ, which contains once again the parity information of A1, A2, and A3. Similarly, these parity information related to the different disks are distributed over the number of disk arrays. RAID 6 is very practical infrastructure for maintaining high availability system. The advantages is that better data redundancy can be obtained and can handle up to 2 failed drives. Then the major disadvantage is that there is a large parity overhead because the parity information has been stored 2 times in the array.